So let's look at how to make plots and also histograms in MATLAB. Let's consider the particular example y equals f of x, which is, we will say, 5e to the negative 0.05 times x minus 2 squared, and all of that plus 3. Let's say that this is the graph that we want to make a plot of. Well, consider what you would do if you were to plot this by hand. You would draw your x-axis, that's the independent variable, and then you would choose a y-axis and choose a range of x. And you maybe plug in some points, and then you would connect the points. Right? But your first thing to do is to choose a range of x. Are you going to graph from negative 100 to positive 100? You're going to graph from negative 1 to 1, 0 to 1, 0 to 100, what have you. So that's really the first thing to do, is choose your range of x. I guess that's the domain. So that's what we'll do in MATLAB. We'll say x equals, and the function I want to look at today, one of the functions, is linspace. Linspace. Actually, before we define x, let's take a look at the help menu for linspace. You see, this is what I want to see here. It can take 3 inputs, x1, x2, n, and it will generate n points between x1 and x2. And they are linearly equally spaced points. So if I say x equals linspace, maybe I want to start at negative 10, and I want to plot to a maximum value of 10, and I want 10,000 equally spaced points there. So I'll write 10,000, semicolon. Here's an example. Here's a good example when I do not want that to be echoed back to me. I don't want vector x, which contains 10,000 points, to be echoed back to me. Okay, so we could alternatively use the colon operator to do this, where we would start at negative 10 and we would increment by 1 over 10,000 all the way to 10. That would do something very similar to linspace. And just to show you on a smaller scale, let's say a linspace negative 10, 10, 5. We'll have that echo back to us. Oops. Negative 10, so I'll start at negative 10, go to 10, increment by 5. So this is what we have, negative 10, then increment, not increment by 5, but 5 equally spaced points. So going from negative 10 to 10. So you can imagine our x, which I'm not going to look at, goes from negative 10 to 10, but there are 10,000 equally spaced numbers between negative 10 and 10. Let me clear the command window. So I've got vector x defined. Now the next thing I want to do is set up y, my y vector. So I'll type y equals 5 times the e in MATLAB is exp for exponent, negative 0.05 times all of those x values, then minus 2, and I want to square each individual x value, so I need the dot caret. Just like the dot times, if I want to multiply x by itself and I want to do that element-wise, then I need a dot operation there, dot caret. Then let me close the parenthesis there, and then add 3. And again, I'll put the semicolon because I do not want all of those values. So for each value in x, it calculated a value for y. and I don't want all of those y values to be echoed back to me. But see, I do have x and y in the workspace now. So what I can do then is type plot, and then you see the documentation comes up and they want the x values first as an input and then the y values. So I'll say x comma y, hit enter, and there's my graph. There's my plot of that function. So what I can do here now is, well, let me maximize it. And you see this button right here? This is a button that I can click to manually edit this plot. So I'm going to click that. I'm going to do everything by hand just to show you what kind of options we have. So now this opens the plot editor, and I can do things like I can give the plot a title. So I've got axes. So down here, so I clicked on axes, and I've got x-axis, y-axis, z-axis. I've got title over here. Let me give it a title, plot of f of x. You see, as I type that, the plot came up, or the title came up above the plot. Maybe I'll label my x-axis. I'll just say x values, and again that comes up on the x-axis. And then let me choose y-axis, and I'll say y values, and then again that is changed here. Now if I want to change the font, I can click font and choose my font size. Maybe I want 30, and so that you can see the numbers changed by 30. But let me click the labels. Let me click y values, and see I've got an option to change that. I can change that to 30, so that makes that bigger. Let me click on the title and make that 30, and click on the x values and make that 30. So I've got that guy there. I can click the actual plot itself, the blue line. Maybe I don't want that to be blue. Maybe I want that to be red. So I can click red. Maybe I want it to be thicker. So I can change the line thickness from 0.5 to, say, 2. Right. Maybe I want the line to actually be a dashed line. So I can have that. And when I'm done, when I think I'm done, I can click this button back. So this toggles between editable and non-editable. So I will hide the plot tools. And I've got that guy there. And I think I can even go to desktop and choose to dock the figure. And so now I've got access to the command window, and I can see my plot in real time. So one of the commands that I like is grid on. So I typed grid space on, hit enter, and then that makes a nice little grid for me. Let me open up the tools again. Let me maximize this. And I can save the figure if I want. I can go to Save Figure. And it wants to save in my MatLab example, so I'll just call it plot.fig and save it. And then it's saved in my current folder. So there it is. So if I X out of that, and X out of these tools. Right. Now if I want to ever look at that plot again, okay, I can just click on it and drag it, and there it is. Good. Another function which I would like to look at, instead of lin space, is log space. So log space, let me bring up the documentation. Okay, is similar to lin space. It generates a row vector of logarithmically equally spaced points between 10 to the x1 and 10 to the x2. So for example, if I said a equals log space of 0, 6, and maybe I only want 5 points. What it gives me is 0, which is 10 to the 0, and then the maximum value is 1 times 10 to the 6th, so that's 10 to the 6th there. And there are 5 logarithmically equally spaced points. So an equally spaced logarithmic point, so this is what's happening here. I've got 10 to the 0, and then an equally spaced logarithmic point is 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5. So this would be 10 to the 0 to 10 to the 5 with 6 equally spaced. Let me do that. So 10 to the 0 to 10 to the 5 with 6 equally spaced points. So here, this is what I wanted. So it starts at 10 to the 0, and it goes to 10 to the 5th, and it creates 6 logarithmically equally spaced points. So a logarithmic equally spaced is when you multiply by the same number to get to the end. That's different than the linear space where you add the same number to get to the end. Alright, so let me clear the command window, clear the workspace. Let's say now I want to create a log space of x, log space, and I want the x values to go from 0 to 10 to the 7th, and I want 100 equally spaced points. So I've got my x. If I want to take a look at it, I can have it echo back. There they all are. Right, you'd want to do such a thing, that is to say you'd want to use log space if your x values have a large range to them. You see, because now the minimum of x is 1, and the maximum of x is, what do we say, 10 to the 7th there. So we've got a long range of x values. If you're interested in a long range, plotting over a long range, then consider using log space. So now I can define my y values again, right, by the same graph. And instead of using the plot command, which I could do, or let me do that first, I guess. Right, that's an ugly window. That's because my range is so large that these large values of x, the function is approximately 0 because this is a decaying exponential. So this is a linear plot. The x values are linearly separated. I can choose to plot on a semi-log plot by using the command semilog x, and then plotting x versus y. And let's see what that does now. Okay, so there's my new plot. And I can dock that, or I can edit it as I did before. So I can choose this button here, and I can click on the figure, and I can make it thicker, the line thicker. I can make it red, or I can make it green. I can give it a title if I want. When I'm done, I can push that button, and I can dock it. So I can look at it. I can turn the grid on. See, notice how the grid appears now. they're not linearly separated, the lines, they're logarithmically separated because this is a semilog plot. That will come up later in your courses, especially with you electrical engineering students. Semilog plots. Okay. So we can use the command semilog x to plot semilog plots. Alright, so I could save that if I wanted to, but I will X out of it, and I will clear the workspace, clear the command window. And let me delete this. Now suppose I wanted to plot the sine function, sine of x, over 2 periods, so x is from 0 to 4 pi. I want to give you a little bit of insight into how MATLAB is forming these plots. So in order to do that, I'm going to set x equal to linspace 0, 4 pi. Okay, that's our range of the x values. And I'm going to just choose 4 points. That's it. You say, well, four points might not be a lot. It might not be enough to make a nice plot. We're going to find out. And we're going to say y equals, we'll call it y sine. Y sine equals sine of x. So here are our x values. Okay, there's our vector. And then here are the corresponding y values. So we've got 4 points there. Let's make a plot of those points. So we'll say plot x comma y sine. Ooh, look at that. That does not look like a sine wave, does it? Nope. So what happened here? Well, the first point is plotted, 0, 0. That's this guy here. I can see that if I click on this guy. This is my cursor, data cursor. Click on that, click over there. You'll see 0, 0 comes up. Then the next point is this one, 4.1888, comma, negative 0.8660. That's this guy down here. So MATLAB plotted the first point and the second point, and then connected them with a line. It doesn't know what's in between, right? So a line is as good as anything. And then here's the third point. This is 8.3776, comma 0.8660, and again it connected this point with the previous point via a line. And then here's the last point. So 4 points is not enough to really capture the sine. So let me X out of that. So let me change my linspace operation here. Maybe I want, instead of 4 points, maybe 100 points. Right, so now here's X. All of those X values, I want to calculate now a Y value. So now I need to recalculate Y sine. So here's Y sine now. And that's the Y value. So now let me plot x comma y sine. Hit enter. There we go. So this is more what we expected, right? 2 periods of the sine wave. You can even make plots that have more than one graph in each plot. So for this example, let's say that I want to plot the sine function, sine of x, and the cosine function. And I want them to be contained on the same figure. And let's say we want the x values to go from 0 to 4 pi. So 2 periods of the sine and the cosine. So I can type x equals linspace 0 is the minimum value, 4 pi is the maximum value, and maybe I want 100 points. And let me calculate the sine. Y sine is equal to the sine of x. Enter. And let me calculate the cosine. Y cosine equals the cosine of x. Okay, now I'm ready for my plot function. So I'm going to plot first x versus y sine. And there it is. So I will dock that. Dock figure 1. There it is. And I can, turn the grid on if I'd like. Those kinds of things. But now I want to try to get the cosine function in this as well. So what I can do is type hold on, hold space on, telling, hey MATLAB, hold on, I'm not done plotting on this graph yet. And then I can say plot y cosine, and there's the cosine. Alright, so let me bring up the plotting tools. So I'll go here. And we can even change the color of one of them. Okay. We can thicken it up. Thicken up the other one. And you see there's display name in the plot tools. So we can call this one the sine. This is the cosine. 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 And you see that now it's displayed there as cosine. We can choose the red to be sine, and it's displayed there as sine. We can even give a command, we'll say legend, and then it requires strings. So we can say the first one is the first one we plotted was the sine, so we can say sine, and the second one, comma, second one we plotted was the cosine. Hit enter, and then here we have the legend that appears. There. So the red is the sine, and the blue is the cosine. So that shows you how we can make two plots in the same figure. If you have many plots that you want to make, all in separate figures, it could be handy to make a script to plot for you. Now, all of the features that we edited manually, such as the label on the x-axis, the label on the y-axis, the title, the grid, the line width, the font size, all of these things, MATLAB has a command, or commands, to change or to edit these plot features. And so you can actually write a script and issue the correct command and put these plots in a loop. And so if you want to generate multiple plots, you put them in a loop, and you can write the commands to edit the plots how you would normally do it manually. In this example, I want to generate automatically the sine of x, the cosine of x, and the tangent of x, each in separate figures. Each in separate figures. And we'll say on the interval of x goes from 0 to 4 pi. So I'm going to create a script, new script, and I will save it as plot example. So the first thing I need to do is generate my x values. X equals ln space 0 to 4 pi, and maybe we want a 100 values. There we go. So I'll comment this as independent variable. Now, let me generate the sine values. So we'll say y sine equals sine of x. And let me generate the cosine values. Y cosine equals cosine of x. And the tangent. Y tan equals tangent of x. Now, and you'll see why in a second, but let me put those data into a matrix. Right now, the vector x has 100 points, and it's a row vector of 100 elements. Y sine is another row vector of 100 elements. It's the sine of all of the x values. Y cosine is another row vector of 100 elements. It's the cosine of all of those x values. Y tangent is another row vector of 100 elements. So let me put the sine values as one row in a matrix, the cosine values as another row in a matrix, and the tangent values as another row of a matrix. We'll call that matrix data. We'll say the first row is y sine, the second row is y cosine, the third row is y tangent. All right. Now I want to generate a plot for each one of those functions, sine, cosine, tangent. And I'm going to do this iteratively, so I'm going to put these all in a loop for I equals 1 to 3. So I know that I'm going to loop 3 times, once for each plot. First thing I need to do is make a new figure. Figure 1, figure 2, figure 3, etc. So this is a MATLAB command, figure II. Figure of II. Figure of II makes an ith figure. So when II is 1, it makes figure 1. When II is 2, it makes figure 2, etc. So I will comment that, make a new figure. Right, so the next thing I need to do then is to plot. Now I've addressed the figure, I've got a new figure, figure 1. Figure 1 is going to be what? Well, I'm going to plot my x values versus, now what do I want to plot here? I want to plot the sine values, but I don't want to type y sine because when it loops again, I want it to be the cosine. And when it loops again, I want it to be the tangent. So I'm not going to put sine or cosine or tangent. What I'm going to do is put the row that I want to plot. So I want to plot the ith row of data, comma, colon. So let's take a minute to understand that syntax. Go way back to the video accessing array elements. The colon operator can be used to access the entire row. So when II is 1, that syntax there, highlighted, is the entire first row of data. That's the sine. Then when it loops back, II will be 2, and that will be the entire second row of data, and that will be the cosine, etc. So I'll say plot ith row of data. Good. Now, at bare minimum, let's give our x-axis a label, our y-axis a label, and a title. So we can say x label is the command we want for the x-axis. We'll call it, and we'll say x values. Okay, y label, we'll say y values. And our title, we'll say title plot of f of x. And there are many more things we can do, right? We can turn the grid on. Let's do that. Let's turn the grid on. And we can adjust the line thickness. And I encourage you to type help plot to find out how to do these things. But we'll stick with the bare minimum here. And we'll end our for loop. And we'll save it. And we'll run it. So here we go, run. And there we go. So it went through the for loop first time and said figure 1. So here's figure 1. Plot x, and so plot the x values with the first row of data. So the first row was the sign. Give the x label x values, give the y label y values, give the title plot of f of x, turn the grid on. Then it hits the end of the for loop, comes back up, sets I equal to 2. Create figure 2, so that's this guy. Plot the x values with the second row of data. Give the x label x values, give the y label y values, give the title plot of f of x, turn the grid on. End the for loop. Come back up, set I equal to 3. Create figure 3, that's this guy. Plot the third row of data, give it an x label, give it a y label, give it a title, turn the grid on. We've got all of our plots there. And finally, I want to show you how MATLAB can be used to create histograms. So let's consider what a histogram does. Suppose your instructor showed you a histogram of scores on an exam. Maybe there's a class of 30. So maybe some of the scores are 80, maybe 82, 90, 86, etc. You don't want to count the number of scores. You don't want to count how many times 80 appears, how many times 81 appears, how many times 82 appears, etc. Because in a class of 30, maybe 80 only appears once. Maybe 81 doesn't appear at all. Maybe 82 only appears once. So your histogram, sometimes it would be 1, sometimes it would be 0, sometimes it would be 1, 0, 0. It's not very interesting. Instead, what your instructor will probably do in this situation is to bin the scores. Instead of saying how many 80s there were and how many 81s there were, maybe how many scores there were between 80 and 89 inclusive. So here's 80 to 89, maybe there were so many scores there, 80 to 89. Right? And then maybe 90 to 100, there were that many scores, and maybe 70 to 79, there were this many scores. Okay, that is more interesting to us. So this requires binning the data. A histogram requires the binning. So in MATLAB, we're going to use the function hist. So if you type help hist, you see histogram, it says hist y bins the elements of y into 10 equally spaced containers. Maybe we don't want 10 equally spaced containers. So you can also give it m if m is a scalar uses that many bins. Or if the second argument is a vector, it returns the distribution of y among bins with centers specified by the vector x. That's what we want. So we're going to control where the centers of our bins are located. Just like the center of this bin, if this was the 80 to 89, the center of that bin was 84.5, right? Or is 80, yeah, 84.5. the center of that bin. The center of this bin was 74.5. So, as an example, let's consider the function, the MATLAB function rand n. And if you go back to the random video, this function, MATLAB claims, takes a number from a bell-shaped distribution with mean 0, okay, so centered at 0, and standard deviation 1. So in this example, what we will do is generate a lot of numbers, maybe 1,000, maybe 1,000,000 numbers, using the rand function. And then we'll bin the numbers together, and we'll plot a histogram, and we'll see if the histogram is indeed a bell-shaped curve. It should be if we do this correctly, because again, MATLAB says that the numbers generated from this follows a bell-shaped curve. Okay, so let me generate lots of these random numbers. Let's say x equals rand n, and I will generate a 1,000 by 1 vector of these numbers and hit enter. So x is in the workspace. If I look at it, here are 1,000 random numbers generated from this function rand n. So you can see some of them are positive, some of them are negative, some of them have magnitudes larger than 1. Okay, they fall in these little tails, we call that. So some of them have magnitudes less than 1, so that falls in the, the heart of this curve. But there they are, and we want to know, do these numbers follow a bell-shaped distribution? Okay, well, let's consider how we might want to bin these values x. Well, I might want a bin centered at 0. That's a bad bin. I might want a bin centered at 0. And I probably don't want this bin to be too thick because the standard deviation is only 1. So maybe I want the next bin, so this bin was centered at 0, maybe I want the next bin to be centered at 0.2, and the next bin to be centered at 0.4, and so forth. And same thing here, but with negative values, so negative 0.2, negative 0.4. So maybe I want a vector of bin centers that goes from negative 10 to positive 10, stepping by 0.2. Well, I can do that with the colon operator. So I will say bins, I'll call this vector bins, negative 10, step by 0.2 to positive 10. Hit enter. And if I want to look at bins, there they all are. So there are 101 bins. They step by 0.2. So here's my bin at 0, right? And here's my bin at 0.2 and 0.4, 0.6, and so forth. So I'm going to take those 1,000 numbers and I'm going to bin them in these bins. So I can use the hist function, hist, and I will put our data, which is contained in x, those are the random numbers, into my bins. And let's see what we get. Yep. So there's our distribution. So that to me looks like a bell-shaped curve. So I think we can trust MATLAB on that. Okay, so we learned lots of different ideas in this video. So let's summarize these different ideas. First of all, we started with Logspace, the function Logspace. And what that did was it took 3 arguments, call this x1, x2, x3, and it generated a vector of numbers ranging from x1 to x2. And how many numbers did it generate? Well, it generated x3 numbers. Equally spaced numbers between x1 and x2. We also saw Logspace, which did the same thing as Logspace, except it generated x3 numbers of logarithmically equally spaced numbers between x1 and x2. And the reason we do that is to set up our independent variable. So we could say x equals that, or x equals that. We set up our independent variable, so that tells us the domain, or the range of the numbers that we're going to plot against. And then we would use the plot function. Plot x versus y. Of course, once we have defined y, so y can be whatever function we like. We looked at the exponential function and the sine and the cosine. And so the function here that's helping us, though, is plot. And we also looked at Semilog x, and it has the same syntax, x, y. And Semilog plotted the x values on a log scale. In case you have a large range of x values and you want to see the plot for that long range, you might want to consider Semilog x. And then we showed that we can edit these plots manually by clicking the correct button. So you can rewind the video and see that button, and you can click that and you can edit basically whatever you want. You can edit the X label, the Y label, the title, the line thickness, the grid, the legend. All of these things you can edit manually. Right. We also saw that you can make 2 plots in the same figure using the hold on command. And we didn't do it, but once you're done plotting, you might want to say hold off. Okay, so these will help you plot more than one set of data in the same figure. Also, we looked at how to plot automatically, now instead of manually, automatically in a for loop if we wanted to generate multiple plots, each within their own figure. We saw that the figure command would create a new figure. We saw that the X label command would give the X access a label, whatever you put inside here in single quotes. Y label, same thing. And the title command, you can give your plot a title by placing whatever you want the title to be in single quotes in these parentheses. Finally, we showed how we can use a histogram function, the function hist, to make histograms. Hist requires two inputs. The first is the data of which we want to make a histogram, and the second is the bin centers